Okay, good morning, everyone. Okay, good morning, all. Today we will start this topic. Okay, all of you, please take out your notes and please go through this. Today we'll do this topic. This is the last topic of the first unit. Okay, unsymmetrical bending. So, what is this? This topic is stresses in beams due to unsymmetric bending. Okay, so what it is actually? Please, all of you, listen. So, in case of unsymmetrical section, when load is applied along the section, bending moment are developed above the neutral axis, okay, as a result of which stresses are also developed. To calculate that stress, we need to use a bending formula, and it is given by M by I equal F by Y. I think all of you earlier already got this in your earlier SEM. This formula is familiar to you. So, while the bending moment about the other axis is zero, but in case of unsymmetrical section or symmetrical section, which are inclined on which a external load is acting about the section is not perpendicular to the symmetry axis, and as a result of which two different component of external load is developed, which give rise to two different bending moment. So what it is say that when a load is applied to any particular section or any cross-sectional area, if we resolve that load into two parts, I think all of you know the force resolution. By that, there are two forces from that we will get two component. Like here, you see, if a load P, if a load P is applied here, you see, if a load P is applied to a surface acting at angle theta, then if we resolve that force into two part component, then we will get P cos theta and P sin theta. I think all of you know this. Along that angle, it is cos theta, and against the angle, it is always sin theta. So, how we will resolve this? Okay. So, this please go through this derivation. So, for this, what we do consider any arbitrary section like this. So, there are two Cartesian axis x and y, as we have already discussed, and u and v are the principal axis. All of you know this. U at the angle theta and also v at the angle theta with the Cartesian axis. Now what we did, we applied a load along this y axis. Okay, this load W, this W load is applied along this y axis. Okay, as you see, W load acting along the y axis through the centroid Z. This is the centroid Z. Okay. So what will be the component of the W along the UU axis and along the VV axis? As we already know, along the angle it is always cos theta, and against the angle it is sin theta. So if we resolve that force into two components, we will get this two value, W sin theta and W cos theta. Okay. So due to this two load, there must be a two bending moment also occurs. So what are the this bending moment along the principal axis MUU and MVV, it will be denoted by M cos theta and M sin theta. So now we have to use this bending formula. Okay, M by I equal F by Y. So F is nothing but stress, all of you know. So we can replace that as by sigma also. So if we simplify it, sigma is given by M by I into Y. Just remember this formula. No need for this derivation. Just we need this formula to resolve the force. Okay. So our main required formula is this. Okay. Sigma is this formula is required. Okay. All of you please remember this formula. This formula we need to use while we solve the numerical. Okay. Sigma is M cos theta by I UU into V, M sin theta by I VV into, and this is U. Okay. Last one is U. This is U, not V. This is this is U. Okay. This is U, not V. So please remember this formula. Okay. We need to use this formula while we solve the numerical. Okay. Please go through this numerical. Okay. What it is said. A wooden beam of cross section 100 mm into 150 mm is used as shown in figure. This is okay. This section, this section to support a sloping Mangalore tile roof. It has an effective span of 4 meter and carries a UDL of 3 kN per meter acting vertically downward. Determine the maximum stress developed in the beam. Okay. So if we draw the beam, this is our beam. Okay. It is given 4 meter span, 3 kilonewton per meter load is applied. UTL, UTL 3 kilometer per load is applied. So if we draw the section, this is our section. It is given dimension 100 into 150 mm. So this is a rectangular section. So we can easily say where is our centroid by half of the, simply half of that Z. Okay, this Z is at 50 and 75. So now we need to find out the sigma maximum stress. Where we need to find out? We need to find out at every point A, B, C, and D. Okay. So these are the values already given in the question. So what we need to do? First of all, we need to find out the maximum bending moment. For UDL, I think all of you know W squared by 8. So simply put this value, everything is given, W is given, L is given, just put, and you can easily find out this 6 kilonewton per meter. Okay. So here it, what is this written? See, since in beam maximum stresses occurs either compression or tensile at the top and the bottom surface. So our required point for the calculation will be A, B, C, D. These 4 points A, B, C, and D. Okay. So we need to find out one by one. So first of all, along the U axis, if we find out the moment of inertia for rectangular section, all of you know what is the formula, BD cubed by 12. So it is simply just put the value, you will get the value, and don't forget to write the unit. Okay, can anyone tell me what is the unit here? Anyone please respond. Okay, fine. mm to the power 4. Okay, so similarly find out for the along the v axis. So it will be v d by 12 again. Just replace the b and d. In the earlier case it is 100 into 150. Now it is 150 into 100. Very simple. So after that, what we need to find out, just remember that formula. For that, remember what we need again, m cos theta. So just put the value m. We already know m is this 6 kilonewton per meter. Such kilonewton meter already we have found it. Maximum bending moment. Just a second. Okay, someone is looking at it. Okay, fine. So after that, you need to find out this m cos theta and m sin theta. It is very simple again. Just put out. Now what we need to do, we need to find out the stresses at every point A, B, C, and D. Okay. So for simplification, we have denoted sigma A, similarly like that, sigma B, sigma C, sigma D. Okay. So for that, what we need to do, just remember this formula. Okay. For sigma, m u by I u into P A plus m v v by I v into u a. This is u a. Okay. This is u a. U a. So everything we know now. M u already we have find out this. IUU, we have already find out this. Just put this to value. For this, remember this, okay? For this P and for this U, okay? See here, what we have used. We have written minus 75 and minus 50. So you may have doubt how it is come, okay? For this, all of you please listen carefully, okay? We have our section. Okay, we have our section A, B, C, and D. Okay, this is a rectangular section. So if we draw the Cartesian axis along this rectangular section, say this is x-axis and this is y-axis. For finding out this P and U, we need to do as per the Cartesian rule, okay? As per the coordinate system. At which coordinate, which, what are the sign? So here you see our A point is in which coordinate? Can anyone say?
Third.
Okay, fine. Third coordinate. So in third coordinate, what is the sign? Please respond.
Minus plus.
Minus, minus plus. Is it?
Yes.
Okay, while I am sharing the screen, you can also speak, okay? Because for while sharing, I'm not able to see your messages. If you are replying a message, it is difficult to see, okay? So you can also speak. It is must be an interactive session, okay? Just simply sitting in the class. Think like we are in the class, okay? As we are discussing in the class, you used to speak like that. You can also speak here. Then only I will come to know now you are following or not.
Yes, sure.
So can anyone tell me correctly at which A is in which coordinate and what is the sign?
Plus minus.
I don't think
Minus
so.
A is third
minus.
coordinate and minus minus.
Okay. So all of you please remember the coordinate system. Okay, as per the coordinate system, you please remember the sign. At first coordinate, this is our first coordinate. At first coordinate, our C point is there. For second coordinate, the B point is there. For third coordinate, A is there, and fourth coordinate, B is there. So as per that coordinate, we need to find out the coordinate of these points A, B, C, D, and we already know what is the dimension. Here it is given 100. So on this side, it is also given along the y-axis. Also, it is given. It is 150.
150.
Okay, already we have the dimension. So this is a rectangular section. So we can easily say what is the coordinate of this point. Can anyone say me now what is the coordinate of this A point? Very simple. If you consider this is the center O along the x and y axis, so at which distance A, B, C, D are? Okay, so all of you please try to find out this coordinate, okay, for every point A, B, C, and D. Okay, so by finding out this point, you just need to put this value as per the sign. If you got the minus, then you should write minus. If you got minus, again you need to write minus. Similarly, if you got plus, and this is wrong, okay, if you got 150,
Around
this
15.
this must be 75. Okay, this is the half.
Yeah, actually the first one.
Please remember this. Okay, this is 75,
And the side
and this
means
is
it's 15.
as again
15.
at B point where we need to find out this B point. As per this sign, you need to write down this hello. Okay, so all of you please follow this. And now other all these things are same. Okay, A, B, C, D. Similarly, you need to find out all the for the all points. Okay, so now here you see, here is a term is written tensile. Can anyone say me why it is written tensile here?
Outward.
See, let me explain you. Someone is saying something, please repeat.
Outward direction.
Okay, fine, that's also fine.
Fine.
Please see this. Okay, this is our section. Suppose this A, B, C, D. I'm just roughly drawing this. Okay, if we put a load, okay, what after the putting the load, if the bending occurs, how it look like? It must be look like something like this. Okay, it is not good. Okay, I'm drawing it by mouse. It is something look like this, is it? If it bends, it is a rectangular section. It not look like rectangular, but it is a rectangular. Okay, all of you please miss match this. So after bending, if it look like this, our point will be here A, B, C, D, and D. So you see at which point tension occurs and which point compression occurs. Can anyone say me?
AB tension, CD compression.
Okay, fine. So here you see. That's why we have written at point A, it is tensile. Now it is clear to you. Similarly, here also you need to write tensile. For B, for C, you need to write tensile. Sorry, compression, and for D, you need to write compression. Okay, fine. Is it okay to you? Is it clear? Is there anyone have any doubt in this? Please ask me. All of you please go once through this numerical, and if you have any doubt, please ask me. Okay. After this, we will go to the another chapter. Okay. Until then, all of you please write the attendance in the chat box. Anyone have any doubt? All of you please go through this numerical. Okay. Okay. Is there anyone have any doubt up to this part? In the next class, we will start another topic. Okay. Okay, I think all of you have understand this. As there is no question. So we will start the next class at 10:15. Okay. All of you please join at 10:15. We'll start a new topic. And is there anyone left to give the attendance?